A newborn calf weighs 40 kilograms. Each week, its weight increases by 5%. Let W be the weight in kilograms of the calf after T weeks. Is W a linear function or an exponential function? So if W were a linear function, that means that every week that goes by, the weight would increase by the same amount. So let's say that every week that went by, the weight increases, or really they're talking about mass here. The mass increased by 5 kilograms. Then we'd be dealing with a linear function. But they're not saying that the weight increases by 5 kilograms. They're saying by 5%. So after 1 week, it'll be 1.05 times 40 kilograms. After another week, it'll be 1.05 times that. It'll be 5% more. After the next week, it'll be 1.05 times that. So really, if we really think about this function, it's going to be 40 kilograms times 1.05 to the t power. We're compounding by 5% every time. We're increasing by a factor of 1.05. Or another way of thinking by a factor of 105%. Every week. So because we have that growth by a factor, not just by a constant number, that tells us that this is going to be an exponential function. So let's see which of these choices describe that. This function is linear. No, we don't have to even read that. This function is linear. Nope. This function is exponential because W increases by a factor of 5 each time T increases by 1. No, that's not right. We're increasing by 5%. Increasing by 5% means you're 1.05 times as big as you were before increasing. So it's really, this function is exponential because W increases by a factor of 1.05 each time T increases by 1. That right over there is the right answer. Let's try one more of these. Determine whether the quantity described is changing in a linear fashion or an exponential fashion. Fidel has a rare coin worth $550. Each year, the coin's value increases by 10%. Well, this is just like the last example we saw. We're increasing every year that goes by as we increase by a factor of 1.1. If we grow by 10%, that's increasing by a factor of 110% or 1.1. So this is definitely exponential. If it was increasing $10 per year, then it would be linear. But here we're increasing by a percentage. Your uncle bought a car for 130,000 Mexican pesos. Each year, the value of the car decreases by 10,000 pesos. So here, we're not multiplying by a factor. We're decreasing by a fixed amount. 1 year goes by, we're at 120,000. 2 years goes by, we're at 110,000. So this is definitely a linear. Can be described as by a linear model. The number of wild hogs in Arkansas increases by a factor of 3 every 5 years. So a factor of 3 every 5 years. They're not saying it increases by 3 hogs every 5 years. We're multiplying by 3 every 5 years. So this is definitely, this one right over here is going to be exponential. And then finally, you work as a waiter at a restaurant. You earn $50 in tips every day you work. Well, this is this should jump out as very linear. Every day you work, another $50. Work 1 day, $50. 2 days, $100. So forth and so on. They're not saying that you earn 50 times as much as the day before. They're not saying that you earn 50% more. They're saying that you're increasing by a fixed quantity. So this is going to be a linear model.